Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Guys, we're going to continue with radicals. And so far, we've learned how to deal with square roots. We've learned how to deal with nth root radicals. We've learned how to write radicals in exponential form and how to write exponential form in radical form. And today, we're going to go a little bit more in depth, and we're going to talk about simplifying radicals using properties now, okay? We know how to simplify, for example, the cube root of 32x to the fourth y to the fifth. Today, we're going to take that and we're going to multiply it to another radical and then simplify. And we're going to take that and divide by other radicals and then simplify. So it's a pretty cool day. I know I'm a little bit of a math dork, so I think it's cool, but I think you're going to have a good time with this. First of all, guys, this is really important, all right? The product property of radicals, in order to multiply the same radical expressions, they must have the same index, period. Got to have the same index. Think about it like this, guys. When you're multiplying variables, in order for you to add the exponents, don't they have to have the same base? Well, this is kind of the same, okay? I need the same index in order for me to multiply and or divide radicals, okay? Give me 1 second, please. Okay, sorry about that, guys. So, they have to have the same index. If they don't have the same index, guys, you can't multiply them by just multiplying the radicands. If they do have the same index, all you got to do is keep the same index and multiply the radicands, the inside, okay? So here, I just want to ask, can you simplify the product of the radical expressions? Well, in this particular case right here, I cannot multiply that because that is a cubed, and this is, no, it's not a 1, it's a squared. Okay, so I can't multiply those traditionally. Now, I can do this though, all right? And I got to throw this at you because I've seen this on SATs, and I don't want you to get hurt. You can do this. Isn't this 6 to the 1/3? And isn't this 2 to the 1/2? Now, I can't multiply them yet because I don't have the same index, but someone just said it. Thank you. Can't I get a common denominator for the fractions 1/3 and 1/2? Thank you, my brother. If this goes to 6, that goes to 2. This goes to 6, that goes to 3. Now I have the 6th root of 6 squared times the 6th root of 2 cubed. Now can I multiply these? Heck yeah. I now have the 6th root of 36 times 8, which is 240 and 288. So I can multiply them by manipulating, okay? I can manipulate the rational exponents to have the same denominator, thereby having the same index. So I can do this. However, straight up, you cannot multiply these the way they are. So no. You can manipulate them, and I can get an answer, but straight up, you cannot multiply those two. Okay, so what I did here with the red, that's just, if you get a question like this, and you only have answer choices, and none of them say not possible, then you know that they went down this other route. Okay? How about for B? Would you be able to multiply these? Yeah, it's going to be the cube root of -8, which equals -2. Done. Would I be able to multiply the 4th root of 7 times the 5th root of 7? No, but also yes if I go exponential. Look at the way this one works. This is set. Okay. This is 7 to the 1/4 times 7 to the 1/5. Guys, does this remind you of anything? If I want to multiply these two together, don't I have the same base? What do you do when you have the same base and you're multiplying them? You keep the base and you add the exponents. So that goes to 20, that goes to 5, that goes to 20, that goes to 4. So that's 7 to the 9/20ths, which will equal the 20th root of 7 to the 9th power. So technically, you cannot multiply these two, but since they have the same base, you could go to exponential form and you can multiply them, okay? How about, yes, sir, my brother? You can't solve this one in this case because I don't have 27s to take out, Papa. So you could do 7 times itself 9 times, but when you break it down to its prime factors, you're going to have 9 sevens again. If it was 3 to the second, it'd be 9. But again, I don't have any. In this case, in order for me to simplify this, my brother, I need 20 of the same value. So even if I had a 3 squared in there, that wouldn't mean anything to me. Now, if I had a 3 to the 20th power, yeah, I could take out 1 3 because I'm looking for sets of 20 in this case. Yeah, the number inside the radicand, yes. Oh, okay. Yeah, you can leave it as 7 to the 9th power. Yeah, to multiply that, that's going to be a crazy amount of... Yeah, if it was 3 to the second power, that's pretty reasonable. I'm a reasonable guy. Thank you, sir. How about the fifth root of negative 5 times the fifth root of negative 2? Can I do it? What would it be? Fifth root of 10. Done. Bye-bye. Can I do this guy right here? Yeah, what would this E be? Fifth root of 42x c squared. Remember, guys, when they have the same indexes, you keep the index and you multiply the radicands, the inside part. I got a square root of x minus 5 to the square root of x minus 5. So this is going to be the square root of, yes, x squared minus 25. Guys, the difference of squares, remember? First term squared minus second term squared. Good job, brother. Last but not least, can I multiply these? Yeah, well, what am I going to get here? Okay, this is where I would differ with that. Most people are going to multiply the 72 and the 10, but that can get complicated. So what I do is I go 72 times 10. I leave them separated. And then I have x to the 4th, y to the 5th. Now the reason why I don't multiply these two guys, am I not going to have to break it down regardless? Right? So why go forward when I got to go backwards? So here this is, actually I'm going to look for perfect squares. It's 36 times 2, and this is 5 times 2. What's the square root of 36, guys? So pull out a 6. A 2 and a 2 comes out as a 2. And what do I have left over? A 5. What's the square root of x to the 4th? And the square root of x to the 5th? Y squared, and I have a y left over. So at the end of the day, my answer is 12 x squared, y squared, square root of 5y. That makes sense, gentlemen. Yes, sir, my brother. Thank you. How do I get y squared? Thank you. Isn't there an invisible 2 here? How many times is 2 going to 5? 2 times, and I have 1 left over. Does that make sense? Okay. Next. In math, we said that a radical expression is simplified when the radicand cannot be broken down any further. In order to simplify radicands, simply reverse the properties of radicals. Here's the procedure. Write each factor of the radicand as the product of 2 factors, one of which is a perfect power of the index. 2. Write the radicand as a product of 2 radicals, one of which contains perfect powers of the index using the product property of radicals. 3. Take the nth root of each power. So, when I see 5 cube root of 24, guys, I start thinking of perfect cubes. Now, I know that a lot of us don't know what perfect cubes are. We haven't memorized them. So for those people who have not memorized perfect cubes, first of all, I suggest you learn them. Secondly, you can break it down. Sorry about that. I don't know why that continues to happen. I see this as 8 times 3. What's the cube root of 8? 2. So this is 10 times the cube root of 3. Knowing your perfect cubes is that beautiful. Now, let's say you don't know your perfect cubes. You can break it down. I do not suggest this strategy for my tests or quizzes. You probably won't have enough time. But this is going to be 2 times 12, 2 times 6, 2 times 3. If I have a cube root, how many of one value do I need to pull it out? 3. So a 2, and a 2 comes out as a 2. 2 times 5 is 10. And I have a leftover of cube root of 3. Does that make sense, gentlemen? Talk to me, guys. I cannot help if you do not talk to me. Okay? Yes, sir. Isn't this a 5 out here? 5 times the 2, a 2, and a 2? Okay. Same thing. Thank you. This is 8 times 2, right? What's the cube root of 8? What's the 8? What's the 8 times 3? What's the cube root of 8? What's 2 times 5? With me? Thank you, kid. How about here? Cube root of 128. Does anyone know any perfect squares that come from 128? Good. 64 times 2. What's the cube root of 64? 4. So I have 4 with a cube root of 2 left over. Then what's the cube root of x to the 7th? How many times does 3 go into 7? And how many x's are left over? Bam. There it is. Cube root of 54. What do you think here? 2 times 27. What's the cube root of 27? So it comes out as a 3. I have a cube root of 2 left over. And what's the cube root of x to the 5th? How many times does 3 go into 5? What's left over? X squared. Talk to me, guys. It's going to get more complicated. Please talk to me. Okay. I'll take your word for it. How about here? I got 4 minus the square root of 20 over 2. Well, I can't do anything with this, but I can simplify. So it's going to be 4 minus. Isn't 20 4 times 5? What's the square root of 4? So this is 4 minus 2 square root of 5 over 2. What do we know about this 2 down here? Right, guys. Good job. It's the distributive property of division. Good. So you divide that to here and to here. So I have 2 minus the square root of 5. Next, negative 2 plus square root of 32 over 4. I can break the square root of 32 up into 16 times 2. So this is negative 2 plus 4 square root of 2 over 4. And again, I can simplify this. So this will become negative 1/2 plus just the square root of 2. Guys, if you do not talk to me, I cannot help you. Please talk to me. Okay. Next, I got the square root of 20 x to the 10th. Okay. 20 breaks up into 4 times 5. What's the square root of 4? So I got a 2 with a square root of 5 left over. How many times does 2 go into 10? So that's x to the 5th, but it's got to be an absolute value. Why? Because I took a odd exponent of 5 out of an even radical, which is 2. 75y to the 6. This is 25 times 3. What's the square root of 25? So this is 5 with a square root of 3 left over. And how many times does 2 go into 6? So that's y cubed, and it has to be in absolute value because I took an odd exponent out of an even index. Yes, no, maybe, kind of, sort of. Sir? You could put it inside as well, but since 5 is already positive, there's no need for it. Thank you so much. But no, that would not be wrong. All right, now, let's go a little bit further. Now let's multiply them. So I've got the square root of 3 times the square root of 15. So that gives me the square root of 45. Square root of 45 is 9 times 5. Square root of 9 is 3. So we got a 3 square root of 5. This is easy peasy, guys, if you know your multiplication tables. If you don't, I'm sorry. Here, I've got the 4th root of 27 times 6. I'm not going to multiply that. What I'm going to do is I'm going to go 27 times 6, y to the 5th, and w to the 11th. Now, why don't I multiply them? Because if I multiply them, I'm going to have to break them down anyway. So I'm just going to start breaking this down here. This is 3 times 9, a 3 and a 3, a 2 and a 3. Now, I've got a 4th root. So how many of one value do I need? Thank you, my brother. So a 3, a 3, a 3, and a 3 comes out as a 3, and I have a 4th root of 2 left over. Are you with me with just the numbers part right now? Now, how many times does 4 go into 5? One time. I have a y left over. Better be an absolute value because I took an odd out of an even. Remember that y has an exponent of 1. That's an odd out of an even. And then, how many times does 4 go into 11? 2 times. So that's w squared. And I have 3 w's left over. Talk to me, brothers. Okie dokie. Next, I got 3 times the cube root. This one's pretty easy. This is 8x to the 5th. What's a cube root of 8? 2 times 3 is 6. And then what's the cube root of x to the 5th? X with a cube root of x squared left over. Guys, are you seeing this? Are you good? Are you good? Okay. Here, I got 4 times the cube root of 48 n to the 4th m to the 9th. 48. How do you think I could break that bad boy up into a perfect cube? 16 and 3 will do, but that's not a perfect cube. 6 and 8, guys. What's the cube root of 8? 2. So now I've got 4 times 2, so that's 8, with a cube root of 6 left over. Are you with me so far with the numbers? Now, what's the cube root of n to the 4th? N with 1 n left over. Why don't I put that in absolute value? Because it's an odd index. Thank you, good man. And then what's the cube root of m to the 9th? M cubed. Not 3, guys. M cubed. So, my brother, thank you. No, I would not put the in an absolute value because I'm coming out of an odd index. It's when I take an odd out of an even that I put absolute value. Thank you. Yes, no, maybe, kind of, sort of? All right. Now, let's talk about dividing. The good news is the same exact thing, guys. You can only divide radicals that have the same exact index. You can only divide radicals that have the same exact index. So, for example, guys, Don't make this a mountain. It's just a molehill. I got the square root of 18x to the fifth over the square root of 2x to the third. So put it all in one big fat square root. What's 18 divided by 2? 9. What's x to the fifth divided by x to the third? X squared. And this comes out to be 3x. Fuagata. And technically, it's an absolute value because I took an odd out of an even. The only time you don't have to put an absolute value, guys, is if I tell you or the book tells you or a test tells you, assume that all variables are greater than 0. If they tell you to assume that all variables are greater than 0, well then guess what? That means all variables have to be positive. So do I have to worry about my absolute value conundrum? No. Okay. But I got to tell you that. They got to tell you that. You got a question, Papa? Okay, thank you. How about here, guys? Got the cube root of 162y to the fifth divided by cube root of 3y to the second. What's 162 divided by 3, guys? 54 is exactly, thank you. So this is the cube root of 54. And what's y to the fifth divided by y squared? Y cubed. 54 can be broken down into 27 times 3. What's the cube root of 27? So I got a 3 with the cube root of 3 left over. And then what's the cube root of y cubed? Fuagada. Done. Does that make sense? How about this bad boy here? In this particular case, guys, I've got almost. I've got the cube root of 6 for sure, right? But what's the cube root of z cubed? So I could take a z out. And what's the cube root of 125 down here? So I can take a 5 out. So my answer is z fifths times the cube root of 6. That 5 came out of the radical, but it came out of the radical in the denominator. Do you understand why it came out of the denominator? You good with this, Papa? Thank you. Thank you so much, my brother. Is it, I'm not being sarcastic, isn't the 125 in the denominator? So when I take it out, doesn't this really come out as a 1/5? Right? Because it's in the denominator. Are you with me, my man? Thank you, Papa. Yes, sir. Thank you for your honesty. Yes, sir. The 2. What 2, Papa? I'm sorry. What 2, my man? But I don't understand what the 2. 125, my brother, breaks up into 5 times 25. And then 5 and 5. So 3 5s come out as a 5. There's no 2. Thank you for caring. Thank you for caring. And then last but not least, I've got here negative 2. Then what do I got, guys? What's the cube root of 54 divided by 2? 27, right? Now, how about this, though? I got x over x to the fourth. So what's that going to be? In the denominator, x cubed. Thank you. So this is going to equal, what's the cube root of 27? So this is negative 6. The cube root's gone. And what's the cube root of x cubed? Over x, because it was in the denominator. Please talk to me, guys. I have a feeling you're not asking questions. Yes, sir. Yes, sir. You're dividing like normal because you have the same index. So 54 divided by 2 is 27. Any leftover goes inside the radical for sure. And then anything that you pull out goes outside. Yes, it's being multiplied to the outside. Thank you, my brother. Yes, sir. Yes, sir, for B. Yeah. Yes, it would change the answer. I'm an idiot. There you go. Sorry. No. Because you don't have 3 more 2s to take out. Thanks, Papa. That was a very stupid mistake on my part. Okay. How about this bad boy? Got the cube root of negative 375x squared y over the cube root of 3x negative 1y to the 7th. So what's the cube root of negative? So what's negative 375 divided by 3? So I've got the cube root of negative 125 in the numerator. Now, I have x to the negative 1. Can I bring that up? So it becomes x cubed. And this y, can I bring it down? So it becomes y to the 6th. So now, what do you got? Negative 5, beautiful. X over y squared. Heck yeah, good job, guys. Heck yeah. No, because this is an odd. No absolute value needed. And then here, okay, this is a really good one. I've got in this particular case the fourth root of 10x squared over 81 y to the fourth. Okay, fourth root. Well, I can't break down the 10 to 4. I can't break down the x into, I can't break it down. I only have 2 x's. However, this 81, this is 9 times 9, which is the 3 times 3, which is 3 times 3. So I can take out a 1/3. I can take out a y down here in the denominator. And then I will be left with a 10x squared. A 10x squared inside the radical. But I can take out an x squared. So actually, I've got x over 3y times the fourth root of 10. I'm sorry, my brother? And actually, that's wrong what I did as well. You can't take out x squared or y squared because it's a fourth root. It's a fourth root. I need 4. I can't take out an x. I only have 2 x's. I need 4 x's. Okay? And then I will finish these last 2. Have a great day. Homework is valid. God bless you. And thank you for a good class. So here, I've got the fourth root of 8 times the cube root of 5. I can't really do that. What I can do, though, is this. 8 to the 1/4 times 5 to the 1/3. And then I can find a common denominator. That goes to 12. That goes to 3. That goes to 12. That goes to 4. So this is the 12th root of 8 cubed times the 12th root of 5 to the 4th. So the 12th root of 8 cubed times 5 to the 4th. I can do that. And then here I got square root of 10 times the cube root of 5. I cannot do that. But what I can do is go 10 to the 1/2 times 5 to the 1/3. Common denominator 6, that goes to 3. 6, that goes to 2. So I've got the 6th root of 10 cubed times the 6th root of 5 squared, which is 25. So I've got the 6th root of 25,000. Okay? And one last thing that I want to explain to you guys is called rationalizing. Rationalizing. When you rationalize, guys, you're taking the radical away from the denominator. Okay? So for example, if I have, let's say, the square root of 4/3. This is going to give me the square root of 4 over the square root of 3, which equals 2 over the square root of 3. Remember when I told you guys, hey, it's illegal to have a radical down here? I was not kidding. It is mathematically illegal. So in order for you to get rid of that denominator radical, you got to multiply the same exact square root to both top and bottom. So if I multiply this by a square root of 3 over a square root of 3, check out what's going to happen. This is 2 times square root of 3. But what's the square root of 3 times the square root of 3 equal, guys? No. Square root of 3 times square root of 3 equals square root of 9, which equals 3. So there's a little law here. When you have the square root of x times the square root of x, it equals the inside radicand. So for square roots, it's easy peasy, okay? It's also easy peasy for nth roots. Let's say that I have, for example, I don't know, let's go, uh, and hold on. Let's say I have 8 over the cube root of 2x squared. Okay, this is where people get messed up. This is a cube root, not a second root, correct? Not a square root. So, in a cube root, how many values do I need to pull one out? I need 3, right? Guys, how many 2's do I have currently? How many more do I need to pull out a 2? So I know I got to multiply this by the cube root of 2 squared. How many x's do I have currently? No, I have 2. How many more do I need to pull one out? So you're going to multiply the top and bottom by the cube root of 2x of 2 squared x. Why modal? Because I have 1, 2. I need 2 more 2's to pull out a 2. I have 2 x's. I need 1 more x to pull out a 2. So now my answer is going to be 8 cube root of 4x over, think about it, what's the cube root of 2 times the cube root of 2 squared? It's the cube root of 2 cubed, which comes out as a 2. What's the cube root of x squared times the cube root of x? X cubed. What's the cube root of x cubed? X. Now you simplify 4 cube root of 4x over x, and bada bing, bada boom, you're done. Sir, my brother. No, at this point, the x, if you bring it up, you're going to make it a negative exponent, and you don't want to do that. Okay? Last but not least, I know you guys want to get out of here. What if I have 3 over, I don't know, the 4th root of 9xy squared? Okay. And this one, be careful, guys. A lot of people are going to think, oh, I need 3 more 9's. I wouldn't look at it like that. I'd look at this 9 as already having 2 3's. All right? So, how many more 3's do I need to pull out a 3? No, I have 2 3's. How many? So I need to multiply by the 4th root of 3 squared. How many more x's do I need to pull out a 4th root? You need 3 x's. How many y's do I need to pull out a 4th root? Bam. And that's what I'm going to multiply to both top and bottom. So my answer would be 3 times the 4th root of 9x cubed y squared over 3 squared times 3 squared is 3 to the 4th, right? But what's the 4th root of 3 to the 4th? 3. Guys, what's the 4th root of 3 to the 4th? That's the whole point of this, guys, to cancel it out in the denominator. So now I have x times x cubed. What's x times x cubed? X to the 4th. What's the 4th root of x to the 4th? And then what's y squared times y squared? Y to the 4th. What's the 4th root of y to the 4th? Y. Fuagata. The 3 is positive, so it does not have to go absolute value. And at this point, when they tell you to rationalize, they'll tell you to assume that all variables are greater than 0. Guys, thank you so much for taking time from your lunch. God bless you. Have a wonderful day. Hope you learned a lot today.